Here slightly different from the exercises we did recently. Now what we're going to start doing instead is we're going to start writing two ovals like this, and we're going to call this A and B. Now the thing we need to note here is that this little part here, this is actually a subset of A, because everything in this area is also inside of A, but everything in this area is also inside of B. So this is known as a subset of A, and it's also a subset of B. This region here is known as A intersection B. It means what's in A and what's in B. Now, the next section you need to be familiar with is what's called A union B. A union B means everything in A or everything in B. Basically means any number that's in either of them, both of them, or just one of them. Okay? So that's basically A union B is this territory here. Okay, so this is known as A union B. The whole thing is A union B. Now, what we're going to do is we're going to put in some numbers, and we're going to see what's going on here. Well, they have 4 and 5 in common. So that puts 4 and 5 in the middle, because that means they're in both A and B. And then we have 1, 2, and 3 for A only. And then in B, we have 6 and 7. Okay. List the elements of A intersection B. Well, A intersection B is quite easy. A intersection B, we discussed earlier, is the middle part, which is just the 4 and the 5. Okay. And for part 2, we need A union B. And A union B, as we discussed just a minute ago, is everything in A or B. So it's going to be 1, 2, 3, 4, 5, and 6 and 7. Okay. Evaluate the cardinal number of A union B. Well, the cardinal number of A union B is all the numbers in A or B. So it's 1, 2, 3, 4, 5, 6, 7. That's 7. Take away the cardinal number of A intersection B. How many numbers are in A intersection B? That's 2. This question means 7 minus 2, which is 5. Next thing. Is A intersection B a subset of A? Explain your answer. Well, it is a subset of A for the following reasons. Everything in A intersection B fits inside of A. So, A intersection B equals 4 and 5. And what you can say there is, but 4 and 5 are elements of A. 4 and 5 fit inside of A. That means A intersection B also fits inside of A. Okay, that's it. Question 3. We're going to represent this on a Venn diagram. Now, this type of Venn diagram is different. Anytime you see U means a rectangle. Okay? And then normal letters like A and B are often represented by the ovals that we've seen previously. Okay? So always start in the middle and work your way out. So this is the smallest part, and then work your way outwards. So what do A and B have in common? Well, they have E and F. So that's E, and that's F. And then we got C and D for A, and G and H for B. Now I'm going to wipe these numbers off. We've used GH, we've used EF, and we've also used CD. That leaves on the outside, these letters don't belong inside A or inside B, so it's going to be A, B, I, and F. Remember to put the universal set here. Okay, next thing. List the elements of A intersection B. Well, A intersection B, once again, is just that middle section in between A and B. It's letters that belong to both A and B, and that's going to be E and F. Then A union B is what's in A or B, which would be everything in this section here in this in A or B. So it's going to be CD, EF, G and H. Okay. Next thing, evaluate hashtag A union B. Well, that means the cardinal number of A union B. How many numbers are in A union B? 1, 2, 3, 4, 5, 6. Or how many letters even? So that's 6. A intersection B is just 2. So it's 6 take away 2. which is 4. And that's your answer to part 3. Okay, and we're done. So I've done 1, 3, and 6 on this exercise so far. Explain why B is a subset of union. Alright, so 1. This is because 1, 2, 3, 4, and 5 are elements of U. Hence, everything in B, every element in B, element refers to the numbers or letters inside B, also belongs in U. See, we can see there 1, 2, 3, 4, 5. Okay. Do the Venn diagram next. Remember, U means a rectangle, guys. So U is a rectangle. Always a rectangle. Here we have U. We have A and B. Okay. So once again, start in the middle, guys. Figure out what's in common with A and B. We have 1, 2, 1, 2. So it's just 1 and 2. And 6 here. And then B is 3, 4, and 5. 3, 4, 5. Okay. And then what ones have we not used? We've used 1, 2, 3, 4, 5, and 6. The only number that hasn't been used yet is 7, and 7 goes on the outside. Okay. Evaluate the cardinal number of U. The cardinal number of U is how many elements are inside of U. So it's 1, 2, 3, 4, 5, 6, 7. 7 numbers in U. And what's inside A union B? 1, 2, 3, 4, 5, 6. So 7 take away 6, which is 1. List the elements of U that are not in A or B. Simply 7. Okay, that's question 6 done. Now we're on to question 8. U is 1, 4, 9, 12, 15, 18, 19, 20. Okay, numbers in U divisible by 2. Well, that would be 4, 12, 18, and 20 for A. And then B are the numbers divisible by 3. That'll be 9, 12, 15, and 18. We see what they have in common is just 12. So 12 will go here. And then inside of A, we will have 4, 18, and 20 left over. And then inside of B will be 9, 15, and 18. Let's make a list of numbers we haven't used yet. We've used 18. We've used 20, we've used 12, and we've used 4. We've used 9, 15. So on the outside is going to be 19 and the number 1. Copy and complete the Venn diagram. Okay, and that's pretty much done there.